Hi guys, Shouvik here. Welcome back to the YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes, so today we have this problems Leetcode 146 that is of LRU cache and it is indeed a very important problems on any interview perspective that you are going to occur, because here like multiple topics we are going to learn actually. So yeah, so let's quickly get started on it. So design a data structure that follows the constraints of least recently used cache. So I guess you guys is aware of what is actually LRU cache. Otherwise, you can see they have given a very diagrammatical view of Wikipedia. You can go through that and to understand it. But yeah, we will understand from the example test case itself. So what they have given, so they have given a LRU cache with initial capacity equals to capacity and initialize the LRU cache with positive size of capacity. Now they have given two more functions. One is a getter functions and another one is a kind of setter functions. So on getter functions, in get they will given you a key, and for that you have to return the value of the key if the key exists, otherwise return -1. Very straightforward. Void put. Now on setter functions they will given key and value, update the value of key if the keys exist, otherwise add a key value pair to your cache. Simple, very straightforward. If the number of key exceeds the limit, that is our capacity, from these operations evict the least recently used key. So that is in our current cache, which one is the least recently used, we have to omit it out. So now the functions have the following things: get, put, and these functions everyone should run in big of 1. Average time complexity should be in big of 1. So here you can see on the example test case they have given an LRU cache. So if we can how we can discuss this, if I am going to take a screenshot of it, I can take a screenshot of it and we can try to import to our OneNote, that is of escape. Is it happening? So stop responding. It's working luckily. So now if we can go here and insert pictures from file, give me run quick, something coming. So now we can go to our screenshots folder. We can choose the most recent one and it should be our screenshot for sure. Yes, we got it here. It is there. Now can we make it a little bit bigger? Yes, we are able to do so. That is quite slow, but we can manage. Yeah, I think we can manage. So now we can try to understand what actually the game here is. I can come here, select this pen. Now we can play our job. So the thing is, when now we have to first get a query of LRU cache of, okay, it's not happening here. If I can select this. Now can I able to write? Yes, I am able to write. And can I write here also? Yes. So here you can see first one is an LRU cache with size of 2. So that means we have to initialize the LRU cache of size 2. So that is the very start of constructor initializations we are going to do. So here actually we are going to learn multiple topics, guys. One is like, oops, that is highly important, object oriented programming that we are going to learn from here for sure. Second one is a very highly important things, which data structures we are going to put, that is of linked list. So that is this LRU cache is kind of a pre-know. You have to know previously that is only a templates. We are going to discuss our entire templates end to end, and you are going to solve any variants of LRU cache on futures if you are going to face any kind of problems on LRU cache. So you should be like master this particular template so that you can solve any variants of it. So LRU cache, please try to put these things to your brain. Linked list of, more specifically, it is a double-ended linked list. So this topic is a must things, and to perform everything in big of 1, we definitely need a standard hash map or a map, any type of like programming algorithm, programs languages you are going to use. So there is a hash map or what is a very standard maps. We definitely need three things for sure. So that is actually the fundamentals of any particular algorithm. Or so I will like multiple times suggest every interview will try to write the code to object oriented programming. And if interviewer is trying to check your object oriented programming principles, he or she will definitely put some LRU cache based problems. So it is a very popular well-known algo to check your object oriented programming fundamentals. Second one is double-ended linked list gameplay, like deletions, insertions, these things like pointers, plug in play with your double-ended linked list pointers. Second one is how you can maintain the things in your map. So that's three things is must needed to solve it. So I am giving you the pseudocode or the intuitions building very initially. So when there is an LRU cache functions is going to be called, so there is an init that is in Python, so we can call it as a constructor. On other language, your class name is going to be your constructor only. So we have a self. So that is nothing but on other language also you have seen. So that is actually this on Java. It is Shouvik, welcome back to the difference. So today we will solve another question from Leetcode itself. So let's get started. Yes. So today we have. Okay. So now where we are. So here on constructor they will give you this one with a capacity. Now tell me guys. So as it is a what? As it is a linked list. So you definitely have to formulate your node contract. So how should our node should be looks like? It's again a class. So it is the object oriented for sure. So your node, and it should have an initial constructor definite underscore and it should have self key value. So these things it should have. It should have. Now any node, what is the bare minimum thing should have? So I can write it. So this key and value we anyhow have to set. So self dot key equals to my key, self dot value equals to my value, right? And we need a next and previous pointer as it is a double-ended linked list. So self dot next is nothing but I am going to initialize. Initially is none, or your programming can support null. Self dot pref is going to be a none. So that is the basic node how actually my default node should looks like. So now on high levels, what actually we have to do on default constructor initialization? We have to store the capacity, whatever the capacity we are getting, self dot capacity. We should store the capacity to be capacity only. Now you have to now create your default data structure here only. So I am going to state you can create a dummy head which is going to point to tail. I can just asking you to set your head and tails, so that basically when you are going to fetch your previous and next, you are not going to get a out of bound exceptions. You are not going to be out of your linked list. So I have popped some head and next in the default constructor itself. So your head is a double-ended linked list. It should point to your tail, and your tail pref should point to your head only. So these things we just have to do. So your self dot head is nothing but a node, new node you can create with -1 as a key. We can do, right? We can do for sure. And your again self dot tail should going to point to your node of -1 for sure, right? So our head and tails has initialized. Now create the links. Now self dot head dot next is nothing but my self of tail. So I have created this forward link. Now the backward link, self of whom? Self of tail dot pref. This should hold my self of, tell me, self of head. So that means my this links has created, right? Agree. Now as we discussed, we need a key to value. What is the node pointer? That map we definitely need. So we can initialize a empty default dictionary or a dictionary altogether. I can initialize to be with dict only, to be of dict only. Yes, I can do for sure. Else what we need? Self dot capacity. Do we initialize it already? No. So let's initialize. Our self dot capacity can be as big as whatever the capacity is coming to my constructor. Coming to the constructor. Here it is 2. Right? And again we need a self dot current size. What is the current size? 2 on empty. It is of 0. So these things we definitely need to our to our empty constructor when it is going to be called to a LRU cache of 2. So now we can quickly go to the code iterations parallelly, because I know it is a complex question for sure. Like, it is not complex, like state management is actually a game on this particular one. If you missed any particular like link pointing, then you are going to get a wrong answer for sure. So that's the reason I'm going to go to the iterate to line by line functions call only. So I have created my class node with def of init to self of key value, key to be key, value to be value, ref to be none, next to be none, right? Done. This done. Now LRU cache init functions head I have initialized with dummy head, node of -1 -1, tail -1 head dot next equals to self dot tail, self of tail of ref to be self of head. These two links has created, self dot capacity, self dot current size to be 0, and self dot dictionary, that is of map, you can say. This done. Init done. Are we done with our init? Yes, init done. Now we have some getters and setters. And we have to handle everyone's to be of big of 1. So now when we are going to get a put call, so initially we have a head and we have a tail, and we know it's pointing to like this only. Now when we are going to go get a get call, so let's first go to the put call only, because after put only we are going to bound to get a get call. So when you are putting, so there are two cases. So now when we are going to get a put call, put on this 1,1, right? When we are trying to put it, so I have to check. There can be two cases. If my current capacity, right? So there are two cases. If that key is already present, then you just have to update it. You just have to update it. But here key is not present, right? So then we have to create a new node. So we will create a new node. So that is our new node of 1,1, right? And we will put to in between of them. So my head of next should be point to 1,1, and it should point to of my tail, right? It should point to my tail. So that is the structure after this 1,1. Then we are going to get a 2,2. It is present in my map? No, it's not present. And I am also updating what is to my key, what is the node pointer. I am storing this node pointer to my default dict. I am storing it, this node pointer, that is my key. For this key, what is the node pointer? Now we are going to get a 2. It is not present, so we will create a new node and we are going to store its node pointer to my dictionary. So and how my structure should be? I should have an head. Next, it should have, now who is the least recently used? So 1,1 is going to be used very far. Now 2,2. So I will put 2,2 here, and I am going to push my 1,1 to be one part ahead, right? So here, see guys, so here actually the beauty. So who is recent now? Between 1,1 and 2,2, who is recent? 2,2 is recent. So the most recent ones is always going to be my of head of next. So head is the dummy ones, I know. That is of -1 -1. And tail is also a dummy ones of -1 -1. So when I am just calling my head dot next, that is the most recently ones is going to be stored here. Now go ahead. Now we are going to get a get call. We are going to get a get calls of 1 only. So if this is present, yes, it's there. How we are going to check? We are going to call to my dictionary only, dd only, and yes, this key is present. Then when we are going to get a get call, so that means 1 is going to be a recently used. So he is going to be the least recently used, 2. So now see the conversations. Now see the transitions. Our head, I know who is the least recently used. He should point to my just of my head of next. So this is going to point to my this. And this, my 2,2 is going to change to the positions. It should go to the tails. So who is the most least recently used? Who is the least recently used? He is going to always be my tail ka previous of tails. So every time in the current state, who is the least recently used is always be my tails previous. And who is the most recently used is always be point to my head next. These things you just have to maintain to your every state here. Now go ahead. Okay, till this it's very clear, Shouvik. Now go to 3,3. Oh, okay. Now I know my size is 2, and now I am out of size. But we have to incorporate 3,3. It is the least recently used now, right? It is the least recently used. Sorry, it is the most recently used, because we have to dump some ones which not exist, and we are also out of bound. Our cache is also fully filled. Then who is least recently used? My 2,2. Omit it, and put your 3,3 to just after your head of next, because that is the point. The most recent ones is going to be point. Now again I am going to redraw it. Then this is of 3,3, right? And it is of 1,1. and its next should have my tail for sure. So that is the structure, that is the state, that is the current state. You have omit this, and as we all know, as we are pointing, and again from your dictionary also, omit this 2s occurrence and store 3,3 to its node star, node pointer, store it to your dictionary, right. These schemes you just have to follow. 3,3 is there. Again now we got a get of whom I got. Are we following correctly? We got put of 1 1, then put of 2 2, then we got get of ones, then we got a put, so that is also done. Put of 3 3, then we got a get of 2. So now get is there or not? No. So that's the reason. If that is not there to your dictionary, return a -1. So we are returning -1. So that is not there in my dictionary, in my cache. Then we got a put of 4,4. Put of 4,4. Okay. Now who is going to be omit? Where is my current structure? Here. Who is the least recently used? This 1 1. Omit it, and put your 4,4 to be at this place. Just of your head of next. So our structure should be, there should be an head. Then we have a 4,4, right? 4,4. Then we have a 3,3. This is now the least recently used, and we have a tail here. We have a dummy tail here, right? Now let's go ahead. Okay, till this it's very clear, Shouvik, and I am going to make sure that our DD should have 4,4 as an entry, and this 1th entry is going to omit out. It is deleted, right. Now what else? Now we are going to get a call to our 1. Get calls of 1. Do we have it? No. Return -1. Again we are going to get a get call. Again we are going to get a get calls of whom? Get calls of 3. So 3 is there, returning 3. And also make sure, so when you are getting a get calls, put that particular note to the just of head names, because that is the most recently used now. Again we are going to get a force calls. You bound to put the values. The force is the most recently used to be 4. Now I am just going to make the two transitions very quickly. So when we are going to get a 3's calls, so where it is. So when you are going to get a 3's calls, so these 3's you are going to put here, and this force is moved here, right? So my structure should be head, then my 3,3. So that is the most recently used. So least recently used going to be my 4,4, and my tail should be this only, right? Then again we are going to get calls here. So this is now becomes my least recently used, and move it to backward. Then again the same structures we are going to make it, right? It is a 4,4, and again we have a 3,3, and again we have a tail here. So that is the structure finally. And now let's suppose if we are going to get a 5,5 to be a put calls. Tell me guys, who are going to be omit? Who is the least recently used? Tail ka previous, just a previous of my tail, it is going to be omitted. This 5,5 is going to set here, and 4,4 becomes the least recently used. If we have to delete them, if 4,4 is going to be deleted. So these things you just have to maintain all the cases. Now we can quickly go to our code iterations, because only the code perspective it is tricky to maintain the pointers, to maintain the state. So we have already covered node initializations, our LRU cache default constructor initializations. Now pending things is here, get calls. Now on get, if the key is present, then what games you have to put, what games you have to play. This key you have to move it to just of your head of next, because that is the most recently used, right? So I have fetched the node pointer self of dd of key. I have queried it, and it give me the node pointer, and I have stored its previous of node and its next node. Previous node and its next node, I have stored it, right? I have stored it because we have just cut that particular node from that particular point, and we are just making the pointer to be set to its previous. The current node previous is going to be point to its next node, and its next node previous is going to be point to its previous node. So that games we just have to play here. So previous nodes next is point to my next node, and next node previous is point to my previous node. So that means the targeted nodes, it's cut out from its particular positions. And where we have to now put it, head connects, we have to put it to my head of next. So let's fetch what is the current head of next is there. So I have calling myself of head.next. So I got the head of next here. And I have to put the particular node, the node that we have just cut it out from its current place, and I have to put it between my head and my head.next. So my head is at self of head, and head.next I just fetched it, and I have to put the cut node to in between them. How I can put? Now my self of head.next is point to the new node, that is the cut node. Node of previous should point to my head, because that is the most recently used. So that previous should point to my head, and my node of next should point to my head of next. So that means the current head of next now becomes my this cut node head of next. So that pointers we have made, and that's the current head of next, it's previous to the cut node head of cut node head. So head of next, that is the current head of next, its previous should point to the cut node. So that is my cut node. And finally we are returning the node value. Because that node is present, whatever its value, return its value. And if it is not present, very simple case, then just return -1. Very straightforward. Now the put game. So I know guys, it's indeed complicated. Like playing the games with the pointers is actually the challenge. So please be focused. Please be make your full attentions on this particular node links cutout set. So that is the games here. Now if on put that key maybe already exists, so then what we have to do, we have to cut it from its current positions and put it to your head of next. That's games only we have just to play, right? We just have to cut it from its current positions, and as this is the most recently used, we have to put it to my head of next. So here you can see exact same code I have written, So these lines are exactly identical to these lines. So here you can see node equals to self.dd of key, previous node equals to node.pref. So every line is going to be identical of what the games we have played here, right? But instead of returning, we have to store the value. We have to just update the value of that particular node. So that's here we have returning node.value, but here we are updating my node.value to be the whatever the value is coming to the functions calls. Exact same games. No other things we have done. So here I would suggest you can put this common play to some helper functions, to some like private functions only to do it, like rather than code repetitions you can get of it. But I think you guys are getting the gist. So the main intentions to making the LRU cache video to make yourself to be in a good comfortable state to play the games to your node pointers, cutting node pointers, setting node pointers, to maintain the state to every particular points very correctly. So that's exactly we have done here. Here we are returning, here we are setting. Now if it is not present, then we have to create a new node. So I have created a new node by calling my constructor functions node with this key and value, and I am storing its self of dd of key to its node pointer. The node that we just created, we have stored it to its key to new node. Now there can be two cases. Now again there can be how many cases? Two cases. Which of this? If my current size is already of capacity, right? Then on that case, who is the most recently used, we have to omit it. And how we know who is the most recently used? That is of just of tail previous. Just of my tail previous is the most like least recently used. The least recently used is my tails previous. Most recently used, my head next. Very straightforward. Repeatedly I am stating, guys. Because that is the intuitions here. So I'm just going to fetch my node to delete. Whom I delete? Self of tail of previous, because that is the least recently used. And how we can delete? So node to delete of previous. Node to delete of previous of next, I should point to my tail. So that means this link is cut off, and self of tail of previous is now pointing to my node to delete, but it should point to my node to delete of previous. So self of tail of previous should point to my node to delete of previous. Cut it. Both links we have cut it. Now what we have to delete? Delete from your dictionary also. So tail of self of dd, I have deleted this node to delete of key. So this dictionary also deleted its empty, right? Now what is pending? New node we have to just set to my head of next. Right? So I have fetched again same code here. Head of next, I have fetched self of head of next, and head dot next of previous should point to the new node. New node of next should point to the head of next, current head of next, and self of head dot next is point to my new node, and my new node of previous should point to my head only, self dot head only. So this is now set to my in between my head and of head dot next. The new node is the most recently used, guys. We have set it. So this is for the setting the new node. This is deleting the least recently used, guys. Now on else part, if we have the size, if we have the liberty to grow further, then we don't need to delete anyone. We just need to set the new node to the head of next. So here you can see we have just pasted the same code. This is just of the same code we have pasted here. Because we just have to don't play the deletion game, because we have still have the size. So if we have still have the size, we have to just write this. How many lines? This 5 lines we just have to write. So here you can see we have write the exact 5 lines that we have just highlighted just to put the new node to between head and head dot next. We have to put the new node. We have put it, and one more games. My current size becomes +1. Yes. That's exactly the games or the node transitions you have to do to solve it. So yes guys, so this is, I know, indeed a very beautiful problems to solve it, and it is very important to any interview perspective. Now we can quickly discuss the time complexity for this particular algo. So I guess you guys should predict on your own the time complexity of every operations we are doing of big of 1 only. Any get, any put we are doing of big of 1 only, because we are just removing the links and creating the links, right? And on space complexity, can you guys tell me what is the spaces we are using? Linked list, the linked list can big as what? How many put calls we have? Calls will be made to get and put as big as 2 into 10 raised to the power n, 2 into 10 raised to the power 5. So I can say our space complexity is bound to be big of n, not big of n, it's more than big of n, because we are using a dictionary also. We have a linked list and we have a dictionary also, so that is also going to be a take of n also. So n plus n, that is a big of 2n. So that is the time complexity and space complexity for this particular algo you can achieve. Now can Leetcode, can you predict the time complexity? Can you man predict please? Yes, big of 1 for get and put average. Yes, exactly the requirements we are able to make, right? So our every get and put is happening in big of 1. It is of indeed constant, because we are playing our games exactly with the links only. And on space perspective, it is of big of n. I am expecting. Can you predict big of capacity or big of n, right? Big of capacity or big of n. So we have put the capacity to be of big of n only. So our capacity can as big of n only. So we have that many only. So I can more generically write it big of capacity only. So it is 2 into big of capacity for sure, right? Because we are using 1 for linked list and 1 for dictionary. Yes, that is the space complexity we can achieve. And yes guys, that is indeed to be the most optimized time and space complexity you can achieve for this particular problems. And I know it is a complex problem, and it is complex, and the mostly very important problems. There can be multiple variants can be make of this LRU cache. So I am highly encourage you guys to solve it to your own. Go try to write the codes in the modular way that we have followed, and try to remove the duplications that we have done. So try to make your code to be less duplicate. So try to follow that, and try to solve at least these problems to your own once, so that you have the comfort zones. You are on the comfort zones to play the games to your list, to play the games to your links. So the linking play is only the game here. The linking play is only the game here. If you missed any linkings, then you are going to get a wrong answer for sure. So that's the reason I am highly encouraged, and it is the mostly highly important problems to any interview perspective. And I have tried my best to explain to you guys. And if you guys are able to understand till this point the exact whiteboardings we have done, the entire code line by line iterations we did, and the entire time and space complexity detailed analysis we did, so please guys, please subscribe to our channel, and please share the videos to your friends circle who are also preparing for top pro company and brushing up their DSS skills. And please turn on the notification, so that when we are going to live to our next video, you guys are going to get the notification as soon as possible. So that's it guys, that's it for today. Let's meet tomorrow with another video question. Bye guys, bye.